Hello guys, and welcome back to another episode of JAMB Chemistry. And of course, today we'll continue our study on chemical energetics or energy changes. All right, and we're going to look at the first and second law of thermodynamics. Okay, I'm sure that this topic is usually very confused, right? A lot of people do not really understand this first and second law. Okay, you just see them. They can state it for you, but they cannot really explain it to you. Okay, so in this episode, we're going to completely deal with what the first and second law. Are going to see the life examples. Are going to relate to life examples so that what to fully understand, or so that I can be able to confidently talk, okay, as a science student outside. So you're not going to disgrace me. You will not disgrace me in Jesus' name. All right. So please just put your heart and mind down and watch this episode to the end, because every episode is very vital. It's very important. Okay. Some of you skip episodes. I love you. Some of you watch 2 minutes. That is all. That's your problem. All right. Okay. So please make sure you like this video. Make sure you subscribe. Even as you are watching now, you can just click on that like button that looks like this. Just like the video, subscribe to this channel, right, and keep sharing. Okay. We're going to this video is sponsored by the O3 School JAMB app. Okay, like I told you, it's all you need to succeed in your exam. I'll tell you more about the app later, but for now, let's because we're going to take a while here. Let's begin with this. All right. So now, the first and second law of thermodynamics, and of course, we're going to start with the first law. First law of thermodynamics. Okay, all right. And the first law states that energy can neither be created nor destroyed, but can be transformed from one form to the other. Okay, so that what energy cannot be created or destroyed, but can be transformed from one point, or from one form rather, to the other. Okay, or it can be what can be transferred from one form to the other. All right, so this law is in tune with the law of conservation of mass. Law of conservation, okay, of mass. Okay, we said that our matter can neither be created nor destroyed. Okay, but it can be transformed from one form to the other. Okay, it's a very similar law. Now, to explain this law is very easy. Just open your mind to understand it. Okay, so let's say, for example, we have a system. Okay, you have a system. Okay, and then here we have, let's say, surrounding. This is the surrounding of the system. Okay, now in this system, heat energy can flow into the system. Heat can flow into the system. Heat energy can flow into the system. Work can be done on the system. Work can be done on this system. Heat energy can flow into this system. All right. And of course, even the surrounding, okay, can do work on the system. All right. That's why we say work can flow, can be done on this system. Heat energy can flow into the system. Work can be done on the system. And when heat flows into this system, right, it gains energy. And that energy is what we call the internal energy. Internal energy. Okay, when heat flows into the system, it gains energy, and that energy is what we call the internal energy. Now, this surrounding can do work on the system. Let's say it can give this system 300 joules of energy. Now, note one thing: when the surrounding loses heat and it is gained by this system, okay, this surrounding now. I'm trying to explain the law that the energy cannot be created nor destroyed, but can be transferred or transformed from one form to the other. All right. Now, this 300 joule did not just come from anywhere. Abi, did it? No, it does not just come from anywhere. Let's say, for example, you want to sell your phone. Okay. Now, you want to sell it for 500 naira. Okay. Somebody gave you the 500 naira, and then you give the person the phone. The 500 naira did not just appear on your hand like that. Did it? No. Okay, you made an effort, right? Someone paid for it. It came from somewhere. Now, this 300 joule that is being gained by this system, that means it is being lost by by this surrounding. The surrounding loses this 300 joule, and then it is now gained by by this system. Okay, so that is why you see that the law of conservation the first law of thermodynamics is in tune with the law of conservation of mass, and of course it's very correct when you say energy cannot be created or destroyed. Okay, they can be transferred or transformed from one form to the other. Okay, the internal energy of this system will increase by what? Plus 300 joule. All right, it will gain what? It will absorb what? Heat. It will absorb heat. All right, so now it's very pertinent to know that in this type of in the first law of thermodynamics, there are three major type of systems you should be in tune with. Three major type of systems you should be in tune with. You must know them. Okay, the first system is called an open system. Okay, you must be in tune with what to call what? An open system. Okay, an open system. You must be in tune with what to call what? A closed system. And then you must be in tune with what to call what? An isolated what? System. Okay, this one is what? An open system. This one is a closed system. This one is what? An isolated system. Okay, now what you should know here is that for an open system, okay, matter can what? Can flow into what? This system. For example, oxygen, okay, from surrounding can what? Can flow into the system. Okay, and energy can what? Can flow. Heat energy can what? Can flow into what? This system also. Okay, so matter and energy can what? Can flow into what? An open system. All right, that's what you should all take note of it. Okay, this matter, that is oxygen, can flow into the system because it is open. Heat energy can flow into what? The system because it is what? It's an open system. All right, so an open system is a system which matter energy can flow into it, can flow into and out of it. Okay, can flow into the system, can flow out of it. Now, a closed system, a system whereby matter cannot flow into it because it is closed. It is completely closed. Matter cannot flow into it at all. But of course, energy, heat energy can flow into this kind of system. So a closed system is a system in which energy can flow into and out of it, but matter cannot flow into it. All right. So now, but for this, in an isolated system, matter and energy cannot flow into an isolated system. It cannot flow into an isolated. The total energy for an isolated system is constant. Matter and energy cannot flow into an isolated system. All right. That's why we say that the change in internal energy, that is delta U. Okay, in what when we're talking about in chemistry, in physics is different. Okay, but the change in internal energy, delta U, is equals to what? Q plus what? Plus W. All right, take note of that. Okay, that the change in internal energy, all right, is what? Delta U, and it is equals to what now? Q plus what? Plus W. All right, let me put it up here. That what? Change in internal energy, U is Q plus W. Okay, this one is in chemistry. Okay, but in physics, delta U is what? Q minus what? Minus W. All right, so please take note of that. Okay, now, so you will say in your mind now, what is different between what? These two. Okay, now I will explain. Now, for chemistry, in chemistry now, okay, W is what? Is negative when work is done by the system. Okay, in chemistry, W is negative when work is done by the system. Now, what do you mean by work is done by the system? Let me use an example of someone who goes to the gym. Okay, to gym. All right. So when you go to the gym, all right, what happens? You carry weight, you lift it up, okay, to a height. Okay, you keep lifting it up. So what happens? You burn what? Calories, isn't it? Now, as you burn calories, you yourself, you are the system. You are the system. You that is carrying the weight is the system. Why those dumbbell, the iron that you carry, all this one that do that is surrounding. All right. So now, what happens as you keep on doing that? You lose what? You burn calories. Okay, you burn what? Calorie. And as you are losing what? Energy, what happens? The total internal energy of your system, will it increase or decrease? Okay. As you are burning calorie, will your internal energy, okay, increase or decrease? So you see that what? Internal energy work will decrease, okay, because work is done by the system. Okay, the system is what? Is doing work. It is losing what? Energy. So what? The internal energy will decrease. That's why we say what? That work is what? Is minus. Okay, it's negative when work is done by the system. Okay, and of course, W is what? Is positive when work is done on the system. Okay, you must understand on the system, by the system. You must understand what difference between what those two. Okay, so in physics, in chemistry, we say that what work done is what is negative when work is done by the system. W is negative when work is done by the system, and it's positive when work is done on the system. The reverse is the case for physics. Now, in physics, okay, W is what is positive when work is done on the system. Okay, and then W is what is negative when work is done by the system. It's the reverse. Okay, it is the reverse here. Now let me explain it. Now when you are in that gym, for example, okay, as you are losing it, now the difference between what these two, the difference between these two, okay, these two is what in physics and in chemistry is that is the point of view taken by the scientist. Is the point of view taken by the scientist. Okay, now in chemistry we usually take what the point of view of the system. Point of view, POV. We take the point of view of the system in chemistry. Okay, but in physics, they take what the engineers take the point of view of the what of the surrounding. Okay, that is why what you are seeing that work done here is what when work is done on the system, it is what it is positive here. Okay, when work is done by the system, it is negative. When work is done on the system, it is what positive. Forward for chemistry. Okay, so now when work is done on the system. Okay, sorry, it's supposed to be by the system. Done by the system now. By the system is positive. By the system is positive. Well, it is what negative when work is done what on the system. On the system, please. Sorry for the mistake. Okay, so I say it is what it is the reverse. When work is done by the system in chemistry, work done is what is negative. Okay, when work is done on the system in chemistry, work done is what is positive. But in physics, when work is done by the system, it is what it is positive. And I said it is because engineers take what the point of view of what of the surrounding. Okay, it is positive because what happens as you carry that weight and you lift it up. As you carry it and you lift it up, what happens? You see that what you lose heat. Now, as you are losing that heat, who is gaining it? Who is getting it? It's the surrounding. So you are losing the heat. You are losing what that energy, that calorie we are burning. It's what being gained by what by the surrounding. That's why it's very very noticeable whenever you go to the gym where there are many people gymming. Okay, even if there is AC there, at a point you will not be feeling the AC too much. Okay, when so many people are there because they are losing what heat energy, they are losing what heat to the surrounding. So the surrounding will be gaining the heat, and that is why, because it is positive, it is gaining the heat. Let's say for a 300 joule is what you are losing. Okay, because the surrounding is gaining the heat. That is why in physics we say that when work is done by the system, it is what it is positive. But for here, it is negative in chemistry because our point of view is the system itself. You are the one that is losing the energy. So as you are losing it, your internal energy will not increase. It will what? It will decrease. Okay, that's why when work is done by the system in chemistry, we say it is negative. When work is done by the system in physics, we say what is positive. So just understand what those two things. Okay. Now also it's very pertinent for us to know that Q when energy is what is absorbed. Okay, Q is positive when the reactants and products absorb what energy. Okay, so Q is what is positive. Okay, it's what is heat energy that flows into or out of the system. Okay, Q is what? Q plus W. Q is what? It is energy that flows into or out of the system. Okay, and it is positive when the reactant and product absorb what energy. That means what is an endothermic process. Okay, it is an endothermic process. Q is positive and it's what? Endothermic. Okay, when the reactant and product of reaction will absorb energy. Okay, it's an endothermic process. Okay, while Q is what is negative, and that depicts what to exothermic process. Okay, when it's what liberates heat to the surrounding. Okay, so we use positive for Q when the reactant and product absorb energy. Negative for Q when the reactant and product release. Okay, energy to the what, to the surrounding. All right, so that's all about what the first law of what, of thermodynamics. Okay, we have seen what all there is about the first law. All right, so you should be able to explain this first law. Energy can either be created or destroyed, but can be transferred or transformed from one form to the other to anybody out there. Okay, so now we quickly jump into the second law. But before we do that, please download the O3 School JAMB app. Like I said, it is all you need to succeed in your exam. For a JAMB CBT exam, okay, you need a good JAMB CBT app like the O3 Schools JAMB app. It is very, very necessary, very important to get an app like that. The O3 Schools JAMB app has all the past questions for all the subjects, so you don't need to go and buy one past question for 1,500 naira outside. Okay, so all the subjects are inside the app. Okay, all you need to do is to activate for just 3,000 naira. Now, let me tell you what that 3,000 naira does for you. There's a classroom feature that has your lecture notes. Okay, you can study lecture notes, take tests according to JAMB syllabus. Structured, we have studied the JAMB syllabus and said that you need to succeed in the exam. So we have created lecture notes for you to study and take tests on those lecture notes to see whether you understood what you read. So each of those lectures, those syllabus is broken down in simpler molecules that you can put in simpler atoms that you can put to absorb. Okay, then there's the question search feature where you can search for question according to topic. Very wonderful feature. Then lastly, we also have the UTME challenge. That one is the one you must participate in. If you go outside, say you want to go and practice on computer or practice on to learn how to do JAMB CBT, they will charge you 1,000 naira per head. Yes. Now, and every mock you take, you pay 1,000 naira outside. Now, in this app, there are up to 20 mocks, okay, on the app. From the beginning, we'll do that mock every Saturday. Every Saturday, you participate in that mock, okay? You win prizes, we'll give prizes to top performers. Apart from, please do not focus on the prize because that is not really the main focus. The main focus is what? Is your progress. Okay, you have to track your own progress and see whether you are understanding what you are studying. All right. Then of course, you can you get used to how JAMB set their questions. You see your results released every week, and that will make you see your progress. You build confidence towards the main exam. Please do not joke with that app. Activation is just 3,000 naira as I'm treating this video now, but it will increase in the future. So it will definitely increase to 3,000 naira, 3,500 naira, or 4,000 naira in the future. But for now, it's 3,000 naira. So when it does, do not say, I saw 3,000. The video man said the teacher said it's 4,000. Teacher says 3,000. Please pass your exam at once. Go and study like your life depends on it. Study like your life. That's the only thing you are doing right now for this period of JAMB. Focus on your exam. All right. So now that's the app. Please go to Play Store, download. It's also available on PC in case you want to practice with your computer. Okay. So just send a message on 09121 515246. Send a message on WhatsApp to this number if you want to download the PC link. Okay, if you want the link to download the software for your computer, okay, send a message to this number on WhatsApp. If you want to activate the app, send a message to this number on WhatsApp. Anything you want to ask about the app, send a message to this number on WhatsApp. Okay, now let's go to the second law of thermodynamics quickly. Okay, the second law of thermodynamics. So if you have a metal rod placed between hot and cold environment, okay, for example, second law now. If you have a metal rod like this, okay, placed between a hot and a cold environment like this, what do you notice? Okay, you notice that that heat. What is the direction of flow of heat? The direction of flow of heat will always be from hot to cold, not from cold to hot. You get right? Heat will always flow from from high temperature to low temperature, and not from reverse. Okay, the only way you can make heat to flow from cold to hot, okay, is when is like is when you apply energy, or when you pump energy into the system. When you pump energy into the system, like for a refrigerator, a refrigerator will take heat from inside of the system and pump it out, and then cools the things in the refrigerator. Okay, so that is how refrigerator operates. So you have to apply energy. You need to pump energy for that to happen. Okay, so heat always flow from hot to cold, from a region of high temperature to a region of low temperature. Okay, for example, also now let's say this is a cliff, okay, and then there's a ball here. Okay, will this ball flow from here to here or from here to here? How will it flow? When the ball want to flow, if you want to come down, it will come from from this top, it will roll down the cliff. Okay, now if you now have a ball here, okay, and then you want it to go up. Not naturally, this ball will not go up if it is down this cliff. This ball will not go to this top. Instead, it will what? It will from this top will come down. From this top, it can come down, but from here, it cannot go here. If you want to make sure that this ball, let's say in your family, you only know how to carry things up, that is the only thing you want to do. Yeah? If you want this ball to go up, okay, what you need to do is to what? Is to apply what energy. You need to pump energy. That's what I'm saying, that heat flows from what? From hot to what? To cold. So it will what? This ball can only roll from what? From high to what? To low. Cannot roll from what? From low to high. If it must roll from low to high, you must apply energy, you must pump energy into the system. You get? So that is what the law of conservation, that's the second law of what? Of thermodynamics. That's what it's telling us. Okay? So now, for heat to flow from hot to cold, it's a spontaneous process. It's a spontaneous process. So it's what? It's a spontaneous what? Process. Okay, for heat to flow, okay, from a region of what? High temperature to a region of low temperature, is a what? It's a spontaneous process. And for a spontaneous process, the entropy of the system increases. Okay, and for a spontaneous process, the entropy of the system what? Increases. Now, in the next episode, we are going to look at entropy solely about entropy. And we define entropy as the rate of what? Jaggerness or scatterness of what? Of a system. The rate of what? Randomness. The rate of disorderliness of a system. That's what to say what entropy is. Entropy is disorderliness of what? Of the system. Jaggerness, scatterness, any word I can use to refer to what? To something be scattered. That is what we will refer to what? As entropy. So we are saying that as heat flow from hot to what? To cold, okay, it's a spontaneous process, and what? The entropy what? Increases. If the entropy is increasing, we call entropy what? S. Okay, so delta S. Okay, delta S will be definitely greater than what? 0. It will not be what? 0. It has to be greater than what? Than 0. Okay, now for an ideal condition, okay, the best that can happen is that delta S will be equal to 0. Delta S cannot be less than what? 0 for an ideal condition. It will not be less than what? Than 0. Okay, it can only be what? Be 0. Okay, but for natural order, okay, for natural processes, okay, delta S is always greater than 0. Now, let me give you an example. For example, now, you clean your room and you travel for 1 year. You clean your room where you set everything the way they are supposed to be set. You clean everywhere, remove all the doors and everything. When you come back 1 year later, if you travel for 1 year and come back to that same room, will that room remain the same? Never. It will never remain the same. Okay? Doors must have covered. Cockroach must have done parliamentary election or presidential election in your house. Okay? But they will have a throne. Things will be scattered. Even some things that you place, you see that they will be tilted to another direction. So you see that for natural order, for natural things, okay, they tend to go disorderly. Okay? Now also, another example, let's say you buy a new car. Okay, and then you leave it for 10 years and you travel, you leave it outside, park it outside, and then you travel. When you come back 10 years later, will that car remain new? It will not remain new. The tires might have deflated, rats might have done presidential election in your inside the car, and you see that they have torn some things. So it will never remain the same. When you carry a glass cup and you break it on the floor, okay? When you carry a glass cup and you break it, when it scatters, okay, is it easy for you to bring them together? No. For you to be able to do that, you need to expend energy. Okay, for you to clean your room, you need to expend energy. All right, so is that simple? That's what the law of that's what the second law of thermodynamics is talking about. Talking about the rate at which natural things tend to become disorderly, tend to turn to the disorderly state. Okay, that is what the second law of thermodynamics. Okay, and of course, that is all about the second law. All right, that's natural processes. Okay, is they are spontaneous, okay, and they tend to be disorderly, okay. The entropy of natural processes is greater than 0. Okay, this is a statement of the second law of thermodynamics. So the second law of thermodynamics is saying that a spontaneous process will occur if there's an increase in the entropy of the system and the surrounding. Okay, a spontaneous process will occur. That is second law of thermodynamics. A spontaneous process will occur if there's an increase in entropy of comfort of the system and what an its surrounding. Okay, so that is the end of this class. Please like the video, subscribe, and what, keep sharing. In the next episode, we're going to look at entropy, and we'll be done with what chemical or changes or energetics. Okay, and I'll see you in that next episode. Thank you for watching.